Assalamu alaikum dear students, hopefully you are doing great and you have worked on your previous work. So now today we are going to discuss the next topic that of same chapter number 6, that is covalent bonding. So for the ionic bond, we could see the electron is completely transferred to the next atom, but not in the covalent bond. In the covalent bond, electron is just shared. As we have checked in the class that how the electrons are shared between the atoms. Yes, we have discussed in the class the model in which we see that the electron is going in the orbit of the next atom, and it looked like that it is a part of the next atom, but not shared to not the transferred to it, but it is revolving in the both. Right, so this is just look like the both are making both are sharing their electrons, and they are just trying to fulfill the deficiency of each other. So just to complete the outermost shell, making it 8 electrons. So this is sharing is caring. That is the covalent bond slogan. So you can see over here the hydrogen has 1 electron in its outermost shell. So hydrogen is sharing its 1 electron with the oxygen, because oxygen has 6 electrons in the outermost shell. But 1 hydrogen is not enough, because oxygen needs 2 electrons to fulfill its deficiency, because it needs 8 electrons in the outermost shell. 1 hydrogen is contributing just 1 electron. From where the next electron would come? Yes, from another hydrogen. So that's why there are 2 hydrogens in the formula of water. So whenever they want to make the water, they need 1 oxygen needs 2 hydrogen shared electron pair, right, to get the sharing of electrons from the hydrogens. So sharing, that's very much important in the covalent bond. 2 atoms, they will share their valence electrons. They share because elements has enough to pull to take an electron away from the other. It means that they can just be the friends in the circle, like they are just making their deficiencies fulfill, right? They are not completely giving the electrons to the next. Okay, that is overlapping. Overlapping means they are joined together in this way that the electrons are revolving in the orbits of both. They are going to the shells of the next atom that is sharing the electron. Similarly, they are overlapped with one another. You see, oxygen is sharing the electron from hydrogen. Hydrogen is also doing the same, right? Hydrogen is taking one of the electron of the oxygen, so may hydrogen get the fulfill. But what you see the difference? Yes, you see the difference for hydrogen. Hydrogen is exception because it needs just 2 electrons to fulfill their orbit, right? There is another example in the periodic table that needs just 2 electrons to fulfill their orbit, the outermost shell. Which one is that element? You can guess. Exactly, that is helium, because helium is the one that is on the top of the noble gases, and it has 2 electrons in the outermost shell, and that is stable. And similarly, hydrogen wants the same stability. But all the other elements in the periodic table, they needs the 8 electrons in the outermost shell. So that's the fact. So that's very interesting hint to memorize and identify the elements. Sorry, not the elements, now they are compounds. To identify the compounds, that which compound is making a covalent bond. If you are given the question and you have to identify that which one are making the covalent bond, you can just see the examples to identify them, and you would see there are 2 nonmetals joined together. If 2 nonmetals are joined together, no any metal, then you would see that is covalent bond. If there is 1 metal and 1 non-metal, then Yes, that is ionic bond. And if they are both metals, that's a metallic bond. That's another discussion, and that's very rare, right? Where they are metals together. But we are just over here to discuss the metal non-metal bond, that is ionic bond, and the non-metal non-metal bond, that is covalent bond. So yes, you could see over here. Let's see how is it happening. Two hydrogens are going to share. Another one going to share. Okay, so this is how it's make the water molecule together. So you could see over here an example of it.
Methane, ammonia, water, hydrogen fluoride and ethanol. You should already know what covalent bonds are and how they form. If you need to refresh, you might want to watch our video, Covalent Bonds, before you continue. So what are methane, ammonia, water and hydrogen fluoride?
So we are just going to watch a video about their examples because we already know the concept.
Why are they special? All of these compounds are small, covalently bonded molecules. The atoms within them share electrons because they have half-full or more than half-full valence shells of electrons. That is, they are non-metals.
So they don't like metals because both are non-metals or team up, right?
Methane is a fuel, ammonia is used in household cleaners, water is a drink and the essence of life, and hydrogen fluoride is used to etch glass. The bonding in methane, ammonia, water and hydrogen fluoride shows a pattern. Methane is carbon, bonded to 4 hydrogen atoms. Ammonia is nitrogen, bonded to 3 hydrogen atoms. Water is oxygen, bonded to, guess how many? 2 hydrogen atoms. And hydrogen fluoride is fluorine, bonded to just 1 hydrogen atom.
So what would be the formula of it? What is the formula of methane now? Yes, CH4, ammonia, NH3, water, no, it's H2O. This is exception. We are writing it as H2O. Then the fluorine, HF.
Carbon, nitrogen, oxygen and fluorine appear in the periodic table in this order, moving along the second row from left to right. Carbon has 4 out of 8 electrons in its outer shell, so it makes 4 covalent bonds. Nitrogen has 5 out of 8 electrons in its outer shell, so it can make 3 covalent bonds to make the shell full. Oxygen has 6 electrons in its outer shell. It can bond with 2 hydrogen atoms to share 2 more electrons. It now has a full outer shell of 8 electrons. We can draw the covalent bonding in these molecules using dot and cross diagrams. You should already have watched our video on dot and cross diagrams. Methane, ammonia and water bond like this. You can also represent them using rings to show the orbitals. Can you draw a dot and cross diagram for hydrogen fluoride?
Yes, that's interesting to create. You can practice it.
Pause the video and have a go. Have you got it? Each structure contains 4 pairs of electrons that sit as far apart as possible. In methane, all 4 are in bonds. This makes methane tetrahedral in shape. Look at what happens when we draw methane, ammonia, water and hydrogen fluoride. Let's look at these shapes more closely. Ammonia has 2 electrons, called a lone pair of electrons, occupying the 4th position. These electrons take up space. We can't pretend they're not there. In fact, because electrons are negatively charged, lone pairs repel bonds even more strongly than bonds repel each other. This makes ammonia less symmetric than methane. The water molecule is bent in shape. Oxygen has 2 lone pairs. Negatively charged lone pairs are slightly attracted to the hydrogen atoms, so there is a weak attraction between molecules. Forces between molecules are a little stronger in water than in ammonia or methane. Water is liquid at room temperature and pressure, whilst ammonia is a gas that is easily liquefied, and methane is a gas. Intermolecular forces are normally very weak in covalent compounds, but in water they are just strong enough to keep it a liquid. A bit more energy is needed to overcome these forces and boil it. If water were not a liquid, life as we know it would be completely different. Now let's look at something a little harder. Ethanol. This contains carbon and oxygen bonding. How would you draw the two kinds of dot and cross diagrams of ethanol? Pause the video whilst you figure it out.
That's for your interest if you want to draw.
Ready for the answer? Dot and cross diagrams of ethanol would look like this. Nope.
It's a little complicated because it's using the CH3, CH2 and OH. So you can skip it if you are not interested. So let's move to the home assignment. So what you would be working on, homework, is your test yourself, that is on page 89 on your neat notebook. And hope you enjoyed the video and hope you are working well on your neat notebook, and also you are reading and discussing the things. If you are stuck with something, you can ask me. Good luck. Allah Hafiz.